Hello, everyone, and welcome to alt.net May. So if you're here, please put a comment in the chat so we know you're here. Hang on, I'll just take off the slides for the second so you can see our very handsome faces just that much bigger. Wow, we've got someone writing in Korean. Is that anyone you know, Francis?
Hang on, I can't get it to. Why can't I see the messages?
Wait a sec or two. So Lord Teaspoon, yes, we are on. Yeah. Here we go, and we've got George. That's good. So yes, Francis is just back from Korea today, and Damian is actually in Sydney, which is a shame we didn't actually manage a physical meetup, but here we are online. Cool. We got a few comments. So, as usual, we've got JetBrains licenses to give away. So I'll make some questions up as we go again. I go through listening to Damian very carefully, and stick around to the end if you want to win a JetBrains license, and I'll ask you these questions. Any other news while we wait a few minutes for any other people to come in, Francis? You want to mention?
We have our first I should say our winter drink up next month. So that was quite popular. The last event, I think we had, I don't know. I mean, we were like about 30 plus people last time. So we're hoping something similar. This event, it was really just a really good kind of cross section of people from like just from different parts of the tech community coming on. I'm hoping to get even bigger kind of cross section this time around. So yes, I'm actually looking forward to it.
Yes, our friends from the Ruby group will be coming along as well with us. So it's a combined one. And we'll probably get some dinner afterwards as well for anyone who's keen to stick around for more. But yes, if you just come for the drinks or drop by or whatever, it's in the city near Town Hall Station. But we'll send you more details, and it's on the website for next month. All right. Well, maybe time to get rolling. Oh, Damian, do you want to give any Yao?
I will do that. I have a slide for that.
Oh, all right. It's all covered already.
It's all covered.
All right. Fair enough. Well prepared is good. So, Damian, you might remember, gave a presentation back, I think it was January, right?
February, I think. Or end of January. Sorry, it was,
Yeah. On the Sydney to Hobart. So we're very lucky to have him back again today.
And I hinted in that. I said, I'll be back. I have something to talk about.
And Damian, in fact, did mention it even at that time. So today we have a real alt.net topic, which is also from the time of alt.net, unsurprisingly enough, when alt.net was really quite a thing. So it's on Nimbus, which has been working in the background for the last 13 years, was it?
Something like that. Yep, 13 years.
Which is Damian's been working on as well. It hasn't just been running.
Yes, there's a whole story there, which I will talk about.
Right. Maybe I shouldn't spoil your slides too much, but Damian's also the tech director for Yao, so you'll see him if you come to the Yao conferences. And yes, he must put in, I think, an enormous amount of effort to make these things happen. Yes, and I must say, we can put in a little thing for Yao as well, that we're big supporters, and keen to go again. Though I fear there isn't one in Sydney this year.
There is not, but I will talk about that too.
All right. Yeah. All right. I'll stop talking and just hand over to you, Damian.
You want to just do the whole talk, James? I'll just send you the.
This is very good. All right, so I'll hand over to Damian, but we're very happy to have him here. And the only other comment was, if anyone does have a workplace or a venue that they think would be happy to host alt.net, please send us a message, because we've only got like really one venue that we go to. So and it's not always available, etc. So yes, if anyone's up for hosting, then we could have more physical meetups, which I think would be fun, and Damian would have been happy to have while he had in Sydney. So send us a message or the chat or whatever if you're interested in hosting. All right, so I'll bring up Damian's slides. Here we go, and hand over. Here we go.
Cool.
Over to you, Damian.
Awesome. Thank you, James, and thank you, Francis. It's great to be here. So yes, I am Damian. James covered a lot of this as well. Yes, I'm based in Queensland, but I'm in Brisbane this week, and I thought I'd timed a whole bunch of things really, really well. But there's no venue, so I'm in Sydney from Queensland doing this meetup from my hotel room. Which, if the slides get a bit blurry, it's probably me tethering to my phone. So I apologize if I have bandwidth issues because I am mobile. But yes, I live in Queensland. I do a whole bunch of things. One of those things is the YAO technical director, which I joined YAO last July, have been at YAO conferences forever and ever and ever, but joined that last year. Outside of that, I'm basically a freelance consultant CTO. I'm a fractional CTO for a couple of things, but I also do a lot of architecture training, architecture strategy, some just pure software dev. I do a lot of stuff. It's the life of a freelancer. You do what comes your way. Yeah, my website is damianm.com, and I'm damianm.com on Blue Sky. I'm not really active anywhere else at the moment because reasons. So yes, that is me. But yes, YAO plugs. I have two YAO plugs. So now, unfortunately, we're not in Sydney this year. We had to make a financial decision to not be in Sydney. So we're in Melbourne and Brisbane. So we have a leadership summit coming up in June, which, yeah, lots of good talks on various aspects of scaling technical leadership and process. So that's coming up, which is probably not too interesting to people in Sydney because we're not there. YAO December again is just Melbourne and Brisbane. But if there are Sydney people that would still like to come to Melbourne, get in touch, because we're talking about doing some discounts for people in Sydney that want to still come to YAO, but have to sort of have the cost of coming to Melbourne. We want to see if we can help out with a discount. So do get in touch. You can find me on those places or on LinkedIn or wherever else. So that is the YAO. That's the YAO plugging done. I'm wearing a t-shirt, but that's all the YAO plugging done for now. All right. What I want to talk about today is this messaging API called Nimbus that I created with a colleague of mine. So I'm going to talk about what it is and why you might want to use it. I'm going to talk about the history of it because it has been, we did launch it nearly 13 years ago, and it sort of had an interesting path. So I kind of want to tell the story about that, partly for the backstory of the project itself, but also possibly something just very relatable as a developer that has side projects and things. So I want to talk about the story of that and sort of, covering some of the burnout and then sort of picking it back up. So there's a bit of a story there. I'm going to talk about sort of what's in it, what I've done in the last couple of months on it. And then, sort of a little bit of the future stuff. So that's what we're going to talk about. All right. So what is it? Nimbus is a .NET messaging API. If you've looked at an in-service bus or a Mass Transit or something like that, it's along those lines. It's kind of similar, and like those, covers multiple sort of backend transports from Azure Service Bus to Redis, ActiveMQ, but also SQL Server and Postgres. And like those things, just handles all of the plumbing. So you just have to write your application code and it will deal with the infrastructure and, connection pooling and message dispatch and all of the other stuff that you would need. But importantly, it handles all of the queue topology, which is sort of where the fun really comes in if you're working with messaging. And then your handles, dealing with failures, retries, scheduling, all of that kind of stuff, and just lets you write the code. Which brings me to, why do I care about messaging? If people haven't done work with messaging, it's a really good alternative in a lot of cases when building distributed applications, and microservices isn't a cool word anymore, but people will still write them. Distributed apps, event-driven systems, HTTP is a very point-to-point synchronous protocol for that sort of stuff, and it's often just the wrong choice for those sorts of applications. And a lot of what I do as a consultant is unpicking and cleaning up after people who tried to build those sorts of applications with point-to-point HTTP and got themselves in a horrible, horrible mess. And where messaging was just a bad choice. And partly it's because messaging is fault tolerant by default. You get, retries and failure handling and back pressure, and you don't need to go and put poly into something to handle your circuit breakers and your retries and put stuff in a queue if it's already in a queue. Messaging is also really good if you've got like a legacy system that's sort of very monolithic and hairy. It lets you pull that apart piece by piece and integrate back in. And a lot of the consulting work that we'll come to that I've done has been using messaging for that, just like breaking up legacy systems and problem systems. It's also great for just doing background tasks, long-running processes, scheduled jobs in systems where you don't want to have a consumer waiting for that. You can sort of return to the consumer really quickly with a task ID and then process that work in the background. And it's also great for doing integration. If you've got some third-party system that is unreliable, which most third-party systems are, particularly payment gateways, you can just sort of send that off and you not have to worry about writing code to deal with asynchronous third-party systems because it's kind of baked into the infrastructure essentially. So why then Nimbus? Again, if you've seen an in-service bus or a mass transit, it is a very familiar API, although not necessarily copied because this is kind of old as well. But it is open source and free, and all of the other options have gone commercial license for various reasons that I don't disagree with. But it is part of the why I picked this back up again. And yeah, it has been running in production for 12 years. In some fairly serious systems. So it's sort of fairly battle hardened, even though I'm just relaunching it now. So if you're using messaging systems in appropriate places, why use a messaging library like Nimbus? And I don't know, in a room you can get a show of hands, but if you are building messaging systems and you go, and I think this is what holds a lot of people back from wanting to actually dive into doing messaging sort of based architectures, is you look at the sample code for the client library for a RabbitMQ or a Azure Service Bus or whatever, and it will show you, you create a connection and you put in your credentials and then you connect to it, and then from that you create a session, and then from that session you subscribe to a topic or a queue, and then when a message comes out, then you have to go and load the code to do it, and it's all pretty ugly. And you look at that and go, well, actually turning that into something that we would want to work with is pretty hideous. So a messaging library just deals with connection management, handles, connection pools, reconnections, like what happens when your network drops out and comes back. All of the different transports and client libraries have their own kind of quirks. So managing your connections, the queue topology and queue management, again, is a really a big one that is a big part of being successful with messaging architectures. Really has a lot to do with how you model your topics and your queues and how you name them. So Nimbus takes care of all of that. And then again, once you've got your queue and you've connected to it, then you've got to pop a message off it, figure out what code you want to run, and then dispatch off to that code. And again, if you look at the sample code for most messaging libraries or most messaging clients, it's not clear. And then again, if your function fails because there's an intermittent, problem somewhere, or your code, whatever reason we have failures, you need to then be able to retry that code, and sort of manage failures and retries and back off strategies. And if this is going to fail all the time, then get it off the queue and put it somewhere else. And then your scheduling as well, which comes off with back off strategies in messaging. If you go, this has failed, and I think it's failed because of some intermittent network fault, or that system's down, we might not want to try that again for 10 minutes. Or you might say, we're going to run a job at midnight, and you can sort of handle all of that. So messaging library just takes care of all of that stuff for you. And my analogy is, we don't typically, in the middle of our application code, go, new SQL connection with these, this connection string, connect to that, create a command, format the command, or write the raw SQL with string concatenation, heaven forbid, and dispatch that, and then having to close the connection and dispose of it. We typically don't do that anymore. We'll use an ORM, we'll use an entity framework, or we'll use a Dapper or a Martin or something like that, because we've got better things to do than just repeating that sort of connection code all of the time. So using a messaging library is sort of like using an ORM abstraction layer instead of just writing SQL all the time. Not that I'm a hater of writing SQL. I like writing me some SQL. But yeah, we don't want to have new SQL connection in all of our application code. So I kind of want to show, I did this talk a few weeks ago in Brisbane. I've done a whole lot of talks on what messaging stuff looks like and what the queues look like, but somebody said, oh, it'd be good if you showed that. So I've added in a couple of scenarios that are the sorts of thing that Nimbus does. And the first one is just sending a command. This is a really simple one. For example, we've got some service that integrates with SendGrid or Twilio or Campaign Monitor or AWS Simple Email Service, something like that. We've got an integration around that, and we've got a service that needs to send an email. And so the basic process, and it's very simple, is we will have a command that says send an email command, and we put that on our bus, and our email service will pick that up and send the email. So that's a really simple, fairly straightforward scenario. And so what the code for that looks like is, we've got a class, which is our command, which is one of the things that Nimbus does, is it puts the messages that we're going to put on a piece of messaging infrastructure. It makes them very semantic, and the semantics is where the magic happens, if you like. So this is a command. It's tagged as an ibus command, and so we've got our send email command, which has a recipient and a subject and a body. Again, this is a simplified scenario. Then our code, we've got a bus, which we might have injected into our whatever through our IOC container. We've got some dependency injection, so we inject ibus into our code, and then we can just say bus.send a command. And then on the other side of that, in our email wrapper service, we have a handler class that's called a send email handler, and you'll see that it's got an interface on there that says I handle command of send email command, and it has a
lot of fun to be had with that.
Sorry?
I handle command.
I love a good marker interface.
Yeah. I just gives you so many possibilities.
I gives you all the possibilities. So yeah, love a good marker interface. But essentially that's what your application code looks like. Again, not in the one file, but we've got a command that command becomes our shared contract across both of our services. So it works really well with .NET. You sort of put all your messages in to some NuGet packages in a private package repository, and that's how you publish contracts. So that becomes super easy. If you've got a contract change, everyone can pull it down. And one side just says, here's my command, send it. And the other says, I handle it. And it happens. So then under the hood of that, Nimbus will go, okay, well, this is a command, and it is handled. Because it's a command, the queuing topology is very simple. It's one queue. I've got in here a simplified name, which is the send email command becomes the name of the queue. In reality, Nimbus makes the thing quite long because we have to namespace commands, and every piece of infrastructure has its own naming conventions and what's allowed in there. But for example's sake, Nimbus will create the actual command on the message broker, whether it's Azure Service Bus or Redis or NATS, which I'm going to talk about, or ActiveMQ. It'll create that. And then on the other side, I might have lots of instances of my email service, but because it's a queue, we get what we call competing consumers. So they'll all connect to the one command and just, pop off the top and do their thing. So that's a really simple example. A slightly more complex one is when we start getting into pub sub and events. So here's an example of, we've got some customer service that will handle, new customer signups. And when we have a new customer sign up, we might want to push that off to some marketing system to send them emails. And we might have an analytics database. We might have a bunch of other stuff as well. And the nice thing about pub sub is when you publish that event, you don't need to care how many subscriber systems there are. It will just push it out and everyone will get a copy. And that's where pub sub works really, really well, because you can evolve and grow your architecture in a very loosely coupled way. So, you might start with this marketing system and then somebody says, hey, look, we want analytics of all the customers and correlated with a bunch of other stuff. You just create that thing on and subscribe to that message, and the infrastructure will manage it for you. So that's a sort of a slightly more complex example. And what our code looks like for that is our message is now an iBus event. And so our customer service, instead of doing a bus.send a command, it will do a bus.publish an event. So we've got a new customer signed up, some correlation ID, an email address, whatever else we want to put in it. And then every subscriber will say, I handle this multicast event, customer signed up. And again, that message contract gets put in a Nimbus NuGet package, pushed out within your organization. You can pull that down and write a handler for it. And you can have as many of those as you like. And so then under the hood, what Nimbus will do is, and different pieces of infrastructure under the hood handle this differently. It'll create a topic, is what they're often called. So we'll create that topic, and then we create subscriber queues for each of those, like each of those services that care. So in this example, we've got our customer signed up topic, and then we've got our marketing system .customer signed up subscriber queue, and we've got an analytics .customer signed up subscriber queue. So every one of those services that cares about that thing will get its own subscriber queue. And so they pull down the messages independently. And so that's a sort of fairly basic pub sub system, which again is a really nice way of just evolving the shape of your architecture, because it is so loosely coupled. You don't need to go and, like, every time you add a system, you don't need to go put an extra call in your customer service. It'll just push it out and delegate it to the infrastructure. So that's our pub sub scenario. And what Nimbus does is it actually gets you get kind of funky as well. So here's one. We might have some product service, and when we add a product to that, we might need a couple of things to happen. One is we might have some catalog service that each instance of our catalog service has an in-memory cache that needs to be updated when there's a new product. So we need every instance of our catalog service to get that message. But then we might also have like a warehouse service, and it again might have multiple instances, but they don't have an in-memory cache, they just have a shared database. So in that instance, we might want to say only one of the warehouse services needs to get this message, but all of the catalog services need to get it. And this is where it starts to get a little bit fun. So the code for that, we've still got our event, our iBus event, which is product published. And in our product service, we still call bus.publish. And then you might notice we've got these different handlers. We've got our catalog service handler and our warehouse service handler, and they're tagged slightly differently. One is the pub sub style, I handle multicast event. And the other one says I handle competing event. And so what happens with that is for the multicast event, all instances of that service will get that message. But the competing event, only one instance of that service gets the event or gets that message, because those two copies of or two instances, or however many instances of our warehouse service will compete for the event. So they kind of feed off one subscriber queue. And so under the hood, Nimbus will do that. So we've got our product published topic. And then in our catalog service, we have this multicast scenario where we basically have a subscriber queue per instance. But then in our warehouse service, we have one subscriber queue for the whole application, and only one of them will get it. So you can kind of mix and match your topologies just through how we mark up our handlers with those marker interfaces. And underneath it, you just don't have to worry. It will just do it. I see a question. What happens if you have dependent events? And I don't know what you mean by dependent events. So if you want to clarify a little bit, I'll see it and I'll come back. It's not typing fast enough. But yeah, it gets really interesting too with retries, because if you were to have a where event 1 has to be consumed first before event 2. So good question. The short answer is you wouldn't typically do that in a loosely coupled event-driven system. There's a concept that you would bring in called a saga, where you would have a service that listens to event 1, takes that data, keeps some state of that business process, and once one thing has happened, then it will then fire off the event for the second thing to happen, or a command for that second thing to happen. You typically wouldn't fire out one event and expect different services to do it in order, because that's then not a loosely coupled system. If the business process was so tightly coupled that one thing needed to happen then the other, you would just have one service that took the event once and did the two things, or an orchestration service that took it and then sort of fired off commands to two different services and kept the state of that business process in memory, which is a concept called sagas, which I'm not covering tonight because that's a whole other topic. But yeah, shorter answer is I wouldn't do that. But cool. So yeah, you can do some really fun stuff, and Nimbus will just kind of wire that up based on the semantics of your handler code. Something I'm not going to go too deeply into is the concept of retries. If say we went back to our simple queue topology of an email service, say our email provider's down or whatever, and this thing fails. One of the things Nimbus will do is say, okay, that failed, let's retry it later. And you can specify, do you just want to go try till it works? Or you might say, hey, that failed, let's wait 2 seconds. It failed again, let's wait 5 seconds, and kind of exponentially back that off. But basically what it does is it'll requeue the message to pop off at a certain time. And different underlying infrastructures have different ways of how they schedule messages. But yeah, Nimbus will handle those retries in case of an error. Where it gets fun though with, say this is, if you have one event and your catalog cache works fine, but your warehouse throws an error, you can't just republish the whole event. because then, the catalog service will get it again, which in this instance, it would be idempotent, but in other instances, you might not want them to get the event again. So Nimbus will do some various things to make sure that they only go back to the subscriber queue that they're meant for. And again, it's just stuff that you don't need to worry about, because a messaging library like Nimbus or Mass Transit just takes care of that semantically for you. So it's one of those things, if you look at the sample code for just the client library, there's a whole lot of work you got to do. So some basic scenarios of how that works. So yeah, part 2, the history, if that's all good, and I'm happy to do questions when we're done. So I started playing with messaging in probably 2009 with N-Service Bus, which was based on, at that time, just MSMQ. If anyone remembers MSMQ, I'm at the point in my career where I'm feeling old. So N-Service Bus was, and now N-Service Bus covers a whole range of messaging transports, as does Mass Transit. But back in 2009 and the early sort of 2010s, it just did MSMQ. I started playing with back then, funnily enough, to do with the yacht race. We did a premium SMS subscription where you could get a text, every hour or a few hours with results of the Sydney to Hobart yacht race. And so we built this premium messaging sign-up workflow and sending SMSs. And messaging was great for that, because you could, most of the SMS providers would hit you with a webhook, but then you would need to respond to them very quickly. They had an SLA that you had to come back very, very quickly. So you could throw a message on MSMQ and handle it in the background and send a message out. Francis, the pain. Yeah. MSMQ was cool. So I started playing with messaging around then. Then in 2010, I joined a consulting company called Redify, which I don't know if people have heard of Redify anymore. They became Telstra Purple and now they're Versant. But I moved to Queensland with Redify, and we built up this really good team where for those sort of first few years of the 2010s, we got to work on some really interesting projects, and a lot of them were failed legacy system replacements. And I'm a little bit of a masochist, I think, because I used to really enjoy it when we would get called in and the company had spent some number of years working on replacing some legacy system, failing miserably. And at that point, everyone was stressed, everyone was cranky, they were out of time and out of money, and they went, can you fix it quickly? And I used to really enjoy that sort of stuff. And there was a team of us in Redify in those days, and we're all sort of working on these rescue projects, and I found them really fun. But we all sort of realized that this kind of asynchronous architectures worked really well for that. Some of them were projects that had failed because they tried to do things very synchronously, like food delivery things that would need to charge a credit card, send an email, get the food order to a store all in one synchronous transaction. And that sounds ludicrous today, and we thought it sounded ludicrous back then, but that's what they tried to do. And we realized that this is a thing where we want to take the request and we saw the state of that, and then we want to independently do all of these processes and then have events come back in when they were done. And so it let us very quickly solve a lot of very hairy customer problems for very upset people, because this was a much more fault-tolerant way of doing it. Or it was a legacy system where people had just been trying to do a like-for-like replacement and failing year after year after year because the legacy system kept progressing. And so we were able to, through messaging, just break chunks out and build new services and integrate it back in. And so between, there was a team, of a dozen of us working across 3 or 4 different projects. And we used N-Service Bus, we used MSMQ, we used Rabbit, we used Mass Transit. In some instances, we just rolled our own for various, reasons at the time. And so we sort of developed this expertise in building these messaging systems, and it was really fun. And then Azure Service Bus came out in Australia, and Redify was a sort of Microsoft partner, very much a Microsoft consulting shop. And so lots of our customers started to say, hey, look, we want to use Azure Service Bus. And at the time, and Service Bus was just MSMQ, Mass Transit was just Rabbit. And so we went, well, let's write our own. Like, we've built enough of this stuff now, let's do it. So one afternoon in October 2014, a colleague and I sat down in the office and, broke ground on a new thing, which was sort of the first messaging library to deal with Azure Service Bus. Again, now they all do all of it. So, and then for a couple of years, we put it onto a whole lot of projects, bunch of projects. We had a bunch of contributions. There was a lot of activity very, very quickly. And to be honest, it was all a little bit overwhelming. And then in sort of 2015, 16, 17, the two of us that were mainly in charge of it took different jobs. I ended up essentially in sort of more leadership management jobs where I was off the code for the most part. My colleague Andrew was off doing other stuff where, again, he was off the code or just not in that space. And it kind of just got a little bit neglected again, the sort of the community expectations on us to do stuff, plus the fact that neither of us were doing this stuff. We just kind of got overwhelmed really and got neglected. Then in 2019, I think I ported it to .NET Core. And then in 2020, I had the, I was actually kind of lucky because I was freelancing and COVID happened and all of my projects died up. And then I ended up on this medical testing, it ended up being COVID testing project. And we needed to launch something in the US that needed to be FDA approved, HIPAA compliant, all sorts of nasty stuff, and do a whole lot of volume. And I kind of went, well, and we were on Azure, and I went, well, have I got the tool for you? So sort of got it working on the latest Azure SDKs, and it was a really good thing for us because a lot of medical software has a very rigorous documentation and testing and compliance life cycle for FDA compliance. And we sort of built this architecture where the platform got certified, everything was auditable, but the individual services, we could eventually release at will. So messaging became a really good way of decoupling this system and saying, look, everything looks like this shape, but the individual services could change. And we got that approved by the FDA. So we were able to move very quickly, and we processed many, many, many millions of messages, in that time on that system. And, it just kind of worked really, really well. And then since then, I've sort of taken Nimbus to various client systems, and I've done training with it and a whole bunch of stuff. But because there was a period of neglect and the .NET Core port was done as a little bit of a side thing and then dived into COVID, a couple of things happened. One is I hit some fairly severe burnout a couple of years ago as a result of sort of freelancing through that period. And then, and I started training with it, and, people liked it. But I had this problem, which was the .NET Core port wasn't on the main branch. The documentation was out of date. The build process was horrible. The versioning process, I was using Git version and Semver, or it was Git version, and I didn't like the way that worked. Separating out integration tests for various different transports was awful. I wanted to add more transports other than Azure Service Bus and Redis because we had a Redis port which was very fast, but wasn't persistent. And I don't honestly do that much Azure work these days. So I had all these things I wanted from it, but A, I was burnt out, and B, I just had this, I don't know if people know about the concept of yak shaving, but I was in this, like, I want to release this properly, but to do that, I need to finish the documentation. To do the documentation, I really want to add a new transport, but I can't add a new transport because everything has this kind of global versioning thing, and really like the new transport kind of have the same version of the core of it. And everything that I wanted to do had 5 things that I needed to do before it. And it was just, for my undiagnosed ADHD, it was just too hard. Like everything that I wanted to look at it just had 10 dependencies, and it was just all too hard. And, you know, on top of that, I was burnt out, and it was just, I just couldn't move forward with it. I was really, really, really stuck. And again, I was running workshops and kind of explaining how to do modeling in distributed systems, and using Nimbus as an example. And, you know, it's a really good example for all of that semantic stuff. And people are like, yeah, but we can't use that. Like, it's not, you know, it's an unsupported thing. Like the builds were on like a private MyGet repo, and you know, it's like, we can't use this. It's not a live public supported thing. So it kind of just sat in my stomach as guilt for many years. And then last year, touring with Yao, I really did get inspired by a lot of people that were doing this stuff, and particularly Simon Brown, who sort of had C4 that he essentially open sourced, and then was doing a lot of training and workshops on it. I'm like, okay, I need to get off my butt and get this out the door. So I dedicated the first few months of this year to just getting it all done, which is why, yeah, when I was speaking with you in January, I'm like, this is, something's coming. And I was really close to having it done. Which brings me on to part 3, the 2026 re-release. Essentially what happened was I just solved all of those pain points. So yeah, like I said, I'm not using Azure Service Bus a lot. I really wanted to do an ActiveMQ port. I do a lot of work with clients that aren't really ready for messaging infrastructure. So I've like rolled a SQL Server queuing system now about 3 different times. So I wanted some new transports. There was something called NATs that I've always wanted to build a transport for. So I have all of those. To get there, I needed a better release process. So I got that sorted out. Some like release and versioning process, I got better. Like it was just overly complicated, and I cleaned a lot of it up, and I used some GitHub Actions and did some stuff there. I can isolate different transports and write integration tests rather than trying to run all of them at once. I just had to clean up a bunch of tech debt and get it to work, and then go and build some documentation. So yeah, basically all of those things in the way, I just found a burst of energy, helped a little bit by Claude. And just made a list, went, what is stopping me from getting this release out? And just sort of over sort of 2 months, just picked them all off one by one. So now I've actually got 8 different transports that I support. So we've got like an in-memory one for testing. Essentially, you wouldn't use that. That would be silly. We still do Azure Service Bus. Still do Redis, which is, you know, quite quick, but not that persistent. I've got a Postgres backend and a SQL Server backend. So if you want that messaging semantics without running extra infrastructure, I do that. Again, I've got lots of my clients, or some of my clients, where managing messaging infrastructure was just not something that we needed to do that day. So we can use a database, you know, for low volume stuff, it's fine. Did an AMQP transport, optimized for ActiveMQ Artemis, which is cool. And then, yeah, there's a server called Nats that I've wanted to use forever. It's written in Go, and it's ridiculously fast. Nats originally stood for Not Another Tibco Server. I don't know if anyone's heard of Nats, but I've always wanted to play with it. It has 2 modes. It has a core mode, which is optimized for pure speed, and then it has a persistent mode called Jetstream that does a bunch of persistent storage. So I've got 8 supported transports at the moment, with at least 1 more to come. And then I did a little bit of benchmarking a few weeks ago as well, which was cool because I knew Nats was going to be quick. So I wrote a little benchmarking app and started to do some testing. My first round of that, I realized that AMQP was the slowest of them all, because I had very naively and inefficiently managed my connections for sending. Basically, it was creating a new session every time I wanted to send a message. So now I've got some connection pooling basically for sending, and it's very, very quick. And what I found was Nats is ridiculously fast. Like I said, we've got an in-memory single process provider, which was just for essentially testing. And Nats is almost as fast as doing it in memory. It's ridiculous. Nats with persistence is still faster than everything else. AMQP is faster than Redis. SQL Server is slow, partly because there's some latency. They actually didn't run a large set with SQL Server, partly because it was slow. There's some latency when you do a database because you've got to poll and put in a wait time, and it's not for high volume stuff. Although I was surprised with just how quick Postgres was in that benchmark. Again, this is not a hugely scientific benchmark. It was just, okay, I keep hearing Nats is fast. Is it fast? And yes, it's fast. It's ridiculous. So yeah, some very rough, unscientific benchmarks. And then documentation. This was my big one. I hate documentation, but I'd just done the site that I talked about in January was we just rebuilt the Sydney to Hobart website on a framework called Astro, which is great at doing static site generation, and Sydney Hobart didn't use it for that at all, but I was in Astro mode, and so I picked that for documentation and found a theme and built documentation, which was one of the big things that was holding me back. The other thing I did was one of those kind of shower thoughts. One night I'm like, spending all this time building a documentation site, but really, if no one is writing code anymore, is there a way of just compressing and feeding your documentation to an AI coding agent? And it turns out there is, and it's called llms.txt. And there's a whole website and a whole standard about it, where essentially you condense your documentation into one big markdown file. And there's a standard that you have it at your website /llms.txt. And you can point your coding agent at llms.txt, and it just kind of sucks in all the knowledge and doesn't have to read multiple pages of documentation. So I played with that, and it works quite well. So I've got an llms.txt for it. So sort of, we'll probably iterate on it some more, but the documentation is optimized for AI coding agents. So that was a fun little discovery. So yeah, and what's coming is I want to do a RabbitMQ transport, partly for completeness, but also there is a RabbitMQ compatible broker called LavinMQ, which is a very high performance, I think designed for IoT applications, very performant Rabbit, Rabbit compatible broker, and I really want to play with that. So I want to do a Rabbit transport. I've optimized my AMQP provider for ActiveMQ Artemis, which is where most of the development in that space is, and it has some good extensions and extra message headers you can put on around sort of native in process or in broker message scheduling. Has some just extensions on there, and I've taken advantage of that, and I want to be able to have a wider support for different brokers. Like at the moment, I'm assuming Artemis is there, but if you were to create a new messaging instance in, say, AWS, you'd get classic ActiveMQ. So there's some work there to sort of put some extensions, and I think I'll just have a configuration extension method that says, enable Artemis extensions or something like that. So just flesh out that option a little bit. I want to add some transactional outbox pattern as well. So if you've not seen that, it's in situations where your messaging infrastructure might not be there for whatever reason, or just some extra reliability, you can transactionally put your message in an outbox database table as part of the rest of your transaction, and then it will retry to make sure that the message is acknowledged by the queue. So I want to add that there. And the next thing I'm working on is actually working on some OTel stuff and putting tracing and metrics in there to if you're using something that can do trace visualization. So that's my next thing. I sat down with Nick Bloomhart, who did Seek and Serilog the other day, and we were hacking on some stuff. So I think my next feature release is going to be just better tracing and visibility and some metrics as well. So that's what's coming next. Cool. I'm going to do a very quick demo. I'm not going to show heaps of code because I've shown what the code does. I just thought I would do, for fun, a very quick demo of, if you were to pull down the code, there is a sample app in there called Stack Cafe, which has a cashier, a barista, and a waiter. And the cashier will take orders and send a message to say someone's just ordered a coffee, and then the barista will make the coffee, and the waiter will hear someone's ordered a coffee, and then wait until it'll hear that somebody's paid for a coffee, and it will listen for the coffee is ready, and if both of those things are true, then it will deliver the message. Again, doing code in a demo like this is not super interesting, but it's there, and it just sort of ticks away, and it's made a flat white for Andrew, and every 10 coffees the barista will drop one and spill it and have to remake it. Just handles the failure. But essentially, this is what this looks like. You can see I've got all the different transports commented out. This is my little testing app. This is what configuring it looks like in an AutoFac module. We register our messaging types. We configure the bus. This is with the NATS transport with the URL and some credentials. I've turned on the Jetstream persistence. You have to give it a name of the application and the instance to get that semantic routing to different things. And then, we turn on Serilog logging. We use JSON for a serializer, and then we build it and start it. So this application called Stack Cafe is just sitting there. Oh, that one. I've got my barista just sitting there making everything. Oops, I spilled Andrew's coffee, and so it's gone and requeued that and remade it. So yeah, I won't dive into a full code demo, but that's it. It's just been sitting there running the whole time on Nats while we've been talking.
Couple of questions for you, Damian.
Yeah.
Come up here. So first one from Luke. What have we got? About multi-language support.
Yeah, interesting. I'll do a few more slides. I haven't. I believe that mass transit does something that you can kind of override its queuing semantics, which I've now said 12 times. So you can kind of say, here is another app that just is going to push these messages into these queues, receive all of them, and then mass transitify them. So that would work. But no, I've not seen anything. It is something I was considering doing something like that, basically building Nimbus Node or Nimbus Python that yeah, again, semantics 13 times, that would handle that. It would be fun. I don't have a lot of use for it because I typically am working mostly in .NET stuff. So no, I haven't come across anything. Francis had a good question, which is, how does Nimbus handle? Sorry, I'm way ahead of you. How do I handle failure scenarios like repeated failures and poison messages? So yeah, so there's a couple of different policies you can put in around when something is poison. Actually, let me come back. So repeated failures, there's a few different policies you can put on. The most useful one is an exponential back-off strategy where you can say, look, we're going to retry it straight away. If it fails again, then wait a few seconds. And then if it fails again, wait a few more seconds. And I've got a fairly naive implementation of that says it's kind of 2 to the power of how many times it's failed or something. So like the longest failure mode is then like a minute. If something fails a whole bunch of times, it becomes a poison message, which is it's going to keep coming back and slowing your app down as it chokes on the exception and whatever else. And so the concept there is what we call a dead letter queue, which again is not our concept. So we keep in the message header how many times it's failed. And so if it's failed more than 5 times, which is configurable, then we'll just move it to a different queue called a, dead letter office or dead letter queue. And then they sit there, and then, you'll get some error logs, and you can go and inspect those messages. And what I don't have yet is tools to manage that. A lot of people will build tools to do that, because you'll see something, you might have a service that is failing for whatever reason. You have a whole bunch of failed messages. And then I think Rabbit has something called a shovel, because you can say, okay, we fixed our service now take all of those messages that failed and dump them back in the top of the pipe, and then they rerun. I've typically built it in apps to be a little bit more specific than that. You might, again, because we can track state of processes, we can say all of these product updates failed, or, in the case of the medical testing thing, all of these test processing failed. You can say select all of the new ones and rerun them, and it will, just resend all the commands for that sort of stuff. So yeah, Nimbus will handle the retries, and then it will put stuff in the dead letter queue if the messages are poison. But there isn't something automatically to go and rerun them. That's typically an application specific concern. Jump back into my slides real quick. So it's 13 times I said semantic now. I like that word. All right, that was my demo. So yeah, kind of a little bit to wrap up. If you're interested, go try it. Go have a play. Again, that little sample Stack Cafe app that I showed you is in the code. So you can, there's a Docker Compose file in there as well that will start up a SQL Server, a Postgres, a NATS, a Redis, an ActiveMQ, RTMS. Spin them all up, and then you can just pick and choose from which transport you want and run that Stack Cafe app and see it all ticking along. It also logs out into Seek. If you've not seen Seek as a logging server, it'll pull that down as well. So yeah, if that sort of thing interests you, go play. Yeah, I'm very excited about NATS at the moment because it is kind of very fun and very fast. So yes, if you are familiar with the messaging space but haven't played with NATS, go have a look. I'm kind of excited about it. And yeah, like I said, so Mass Transit and then Service Bus all cover Azure Service Bus. They cover Rabbit. They cover Postgres. They cover SQL Server. Yes, the T in NATS was TIBCO. So Derek Collison worked at TIBCO and then left and needed a messaging service. So he's like, all right, I'm going to build another one. Yeah, all of the sort of competitors, and I hate that word because we're not, to Nimbus cover lots of different pieces of infrastructure. I don't think anyone else does NATS. So it means that, yes, Nimbus is the... sorry, James, I just thought that was a question about semantic. Yeah, I think Nimbus is the best way to do NATS on .NET. Sorry, I'm distracting myself. Cool. What else was I going to touch on? Oh, yeah, the sort of open source philosophy thing. This one has been on my mind a little bit. So again, like part of the reason for burning out the first time around was just a whole bunch of people putting a whole bunch of pressure on us to add their stuff. And, something that I've observed in the world at the moment is Mass Transit went closed source and commercial. Jimmy Bogard's taken a lot of his stuff closed source and commercial just because there's a lot of people that will put a lot of demands on free software maintainers for no return. And I don't want to do that. I've burned out hard enough already and I don't want to do it again. So I've kind of built a little bit of philosophy around like, this is free. It's going to stay free. But I'm working and I've got a document up on the website around sort of some boundaries, which is the software it's free, but I'm not basically. So I'm not, the other thing that's happening at the moment is, people's coding agents are allowing them to drop drive-by PRs on repos at an enormous rate. And so a lot of open source maintainers are putting guards and controls in, like, unless you're an approved submitter, your stuff's just getting closed. And so I've been thinking a lot. This is more of a philosophy thing, but been thinking a lot about this. Is just, I'm not, I've got a document up there that says if you drop a PR in here, and we've not talked about it first, it's getting closed. It's not personal. I just don't have time. Obviously, if there's bugs, I want to fix them, and I want to build a community using the sort of GitHub discussion stuff, but I'm not going to be at the beck and call of people. And one of the other things is a lot of the, and again, like, this software has run in production for years and years and years and done millions and millions and millions of messages. I know it works. But what I've observed through my consulting and my training is where most people go wrong with this stuff is they sort of get the modeling wrong. So, this is a thing that I do is architecture and training around how to model distributed systems. So yeah, I'm putting this out there for free, but one of my philosophies is I'm not going to do people's work for them. There's help here. I'm going to charge for that bit rather than the software, essentially. So yeah, training, consulting, architecture reviews, that sort of stuff is my headspace on that. And with that, that's the end of the talk. So yeah, if anyone's got any other questions but yes, thank you for listening for an hour. It is hard to do this. I've seen a few comments, but it's hard to do this with no feedback.
Yeah,
yes, thank you for listening and indulging me.
See, we got another question here. Not really. Just about Nat's a comment from Luke. Do we have any other questions for Damian?
Actually, I've got a question.
Excellent.
Like, how many do you have? I don't know if you've got a rough idea, but of maybe companies or systems that are using like Nimbus that we might have heard of?
That's an excellent question. So I don't actually have good stats, because again, it was used a lot, but because it was neglected for a bunch of time, I know some companies migrated off it to mass transit. I know of some companies that forked it to move it to .NET Core earlier than I did. And I know that some of them are running private forks still. I've got a bunch of my consulting clients that are using it. So that's, like half a dozen different things using it. But I've just relaunched it. So there's not, it's not in the thousands. There was the medical testing company that I talked about that was short-ish lived, that they lived for about 2 years. There's a whole story there. And it was a very, very big spike. And now they're not. So yeah, I don't have a good answer. The number is not huge at the moment. That's sort of why I'm getting out there and doing talks, because there is demand for this, because a lot of people were put off by the charging model of mass transit in particular, which, don't get me wrong, I completely understand where they're coming from. There's a lot of people made a lot of money running software on that and not paying them a cent. So yeah, this is a relaunch, so there's not that many people in the wild using it. That said, there's been a bunch of NuGet downloads since I launched it, so someone's playing.
Fair enough.
Sorry, Francis.
No, it's all right. Yeah.
But certainly, if anyone here is interested in experimenting with it, I would love to hear about it. And yes, while I've put that, the software is free, but I'm definitely interested if you are wanting to get it going. I definitely want to get some momentum behind it.
The MIT license is pretty generous as well, rather than one of the Apache 2s or something a bit stricter. So you're not planning to make it a paid model at any?
No, I don't really have any interest in doing that. I mean, who knows in 10 years' time what I decide to do. No, I think what I'm more interested in doing is doing the training and the architecture reviews and working with developers who want to use it and working with them to do it better. If I were to add paid stuff on there, it might be extra services that attach. Like we've prototyped some interesting visualization options in the past. Maybe something like that. But no, I actually really enjoy doing training and modeling, because that's where I see people get into the most trouble, is just not understanding how to model distributed systems well. And that's what I'm more interested in, monetizing, if anything, rather than the software.
Oh, fair enough. And I think you mentioned you start with Andrew. Is it still involved, or is it pretty much you?
No, he's not really involved. He's got his hands full with other things, but I do still see him a lot. He's actually, so Andrew Harcourt was my colleague that I wrote it with originally, and yes, funnily enough, he's actually gone to work for one of the companies that had a private fork. So he and I were talking about me working with him to get off of their private fork back onto this and implement NATs as well. So he's still on the sidelines. He doesn't have the interest in being involved in it.
Oh, very cool.
So yeah.
At this point, maybe I'll switch to questions for the audience. So is everyone ready? I have collected a few questions. I thought I might start with a hard one. And if people can't get the answer, we'll go for easier ones as well. So Damian, you can correct me or choose the right answer if I get it wrong as well. So feel free to jump in. What does iHandle competing event do as the interface? As opposed to the other interfaces. One's typing, might be Francis. So answer in the chat.
A hand leading event, yeah. I need to do that soon too.
You'd still answer the question if you want. We can do another one if you know the answer. You're a victim of your own success. Sorry, so not that one.
Sort of, but no.
Hey, I think we have an answer.
Yeah, that's good.
All right. Quite sure how to say your handle, but FYT milk. Say it. Please send me a meetup message, and including your email address, and I'll send you the JetBrains license. So just send that through. So that's excellent. So I wasn't sure if anyone was going to get that one. So good listening and paying attention.
It's called the competing consumer pattern. It's basically there's one event and all the services will compete for it, and the first one to get it wins.
That's right, and that's why you're the winner for the first one here too, which just happens to fit nicely.
I see what you did there.
So yes, the next one is a really easy question. So answer quickly. So can you use Nimbus with a database backend, or only with like Redis or some sort of messaging backend?
Lorenz event maxing.
Well, it is Microsoft after all.
I probably, well, yeah. I would need to install Windows. I've built a lot of stuff on MS Access in my time. Did I ever add MSMQ to it? No, I haven't. I haven't added MSMQ. Does MSMQ even exist? Probably does.
Probably does. It's probably some internal systems using it.
I tend to avoid Windows as much as I can at the moment.
Do we have an answer on this one? This one's just a yes or no, so it should be pretty easy. After people got I handle competing event.
Yes.
Yes. All right.
34.
So you win one. All right. Good job. Very good. All right. So we have 2 winners. By the way, on the Postgres one, I do vaguely recall it's got some special handling for queues more than just tables and things. But in the world of Rails, there was some queuing stuff done recently, and I think it had some extra handling that was more efficient than just the table.
Yeah, it's got a query. Let me find it. It runs a. I just got some skip locked on there. For update skip lock lets you have multiple consumers without blocking.
Is that why it's faster than SQL Server?
I don't know, actually. I do need to dig into that. I think just, is there anything that Postgres can't do?
It seems to have so many add-ons for everything, right?
It is quite an incredible piece of software. I've spent a lot of time using Martin from the Critter stack, and like that is incredible as just a rapid application development thing, as a document database. And then I've done stuff where I've built things in Martin and then done materialized views off the indexed duplicated columns in Martin to do full text search. Like it's an incredible thing.
Yeah, it does seem like if you want something, it just happens to have it, and you don't actually need more infrastructure. You can just lean on it. It's not the absolute.
It is absolutely a Swiss Army knife. It's fantastic.
All right. Well, I suppose we're ready to finish, but thank you very much, Damian, for the talk.
Thank you. Thank you. Thanks for having me. It's been an absolute pleasure.
It's really been a messaging theme, actually, except for AI, which is, of course, a theme that is inescapable these days. But yeah, this year, I think it's been a lot of messaging, and it's really good to talk about it more and have it more widely used as a competing approach to just calling an HTTP endpoint. But also, yes, thank you for doing the background on it and explaining the advantages of the library and why it's easier rather than just going low level and all the rest. So
yeah. Cool. I'm glad people enjoyed it. Thank you. And yeah, if you want to play, track me down and say hi.
Very good. And if anyone wants to give a talk, of course, send us a message, and we'll book you in for a month in the future too. And don't forget the drinks next month, which will be definitely good to see everyone in their human faces over alcohol too. So we'll see you all at that. And yeah, Damian and Francis, stick around if you want for a little bit.
Cool.
Ending now. Goodbye, everyone.
Bye.
Bye.